Hello everyone. In this video I will present you some ways of how to characterize some objects in the manner of their spectral information, and in the second part I would like to show you how to use this information for a automatic classification approach, which is called the k-means algorithm, or also known as the unsupervised classification. To do this, we will first need some kind of layer stack, which will represent your scene of your interesting scene, like our scene here in Berlin. I've done a subset of the scene, so we only have here the city of Berlin, as you can see here. And so first part is how to get in spectral information about an object. So we will do that on a full screen mode, and therefore you have some kind of tools here. You can use the start, update, inquire cursor, as you can see in the lower left corner, and this will show you some kind of cross in the middle here, which you can turn everywhere or lay down everywhere you would like to. And let us suppose to concentrate on this pixel, that is the hangar from the airport Tempelhof, I think, and you will get some information about this special pixel. First of all, his location in geographic coordinates, which is represented here in UTM coordinates. His position in the file itself, so it's the pixel number 690 and 660 in the Y direction. And as you can see in this row or column, I don't know exactly, you have the file pixel values. So it's the digital numbers which the sensor, so the ETM plus sensor, received. And you will find some high values in the first three bands, which is the visible light, then a lower value here in the fourth band, which is the near infrared, quite a high value in the fifth band, and in the seventh band, which is the sixth layer, we have done the layer stack here with the layer with the bands 1, 2, 3, 4, 5 and 7, has a smaller value, and yeah, it is represented by the color of white, or whitish color here in this true color pixel, true color picture. And if we turn the cross into some kind of wood area, this is a park region, or a park in near to the airport, you can see that this trees or vegetation area has other values. As you can see here, you have really low values in the first three bands, a higher value in the fourth band, and some kind of near low values in the fifth and in the seventh band. And as you can see, this values doesn't change so much if you are just using the information in this park area. We can also go into some kind of woodland here in the Grunewald. Let's change this tool here once again, and you can see here that the values are nearly the same. So just have a look on that. Low values here in the bands 1, 2, 3, higher value in the fourth bands, and lower values in the fifth and the seventh bands. So this is one possible way of showing the spectral information of a pixel. A second way is to use this profile tools, and for profile tools you have three different choices. First of all, you can have a spectral profile. I'll show you that. Okay, please calculate some statistics. I need that to do it now. Okay, therefore open the image info, use edit, compute statistics, ignore values of 0, and go ahead. There we go. We are finished now. Once again, use the select profile tool, spectral information, and there we go. So this is a new window, and you can use this new profile point in viewer tool to select a point in the viewer, and you will get the spectral information of this point in a graph. So it is representing first band, second, third band, fourth band, fifth band, and the 7th band in this point. And one major advantage of this tool is that you can select different points in your area of interest and have some kind of overlaying graph of the spectral behavior. So you can see that all these vegetation areas here, or all these pixels, are in an wood area or forested area. You can see nearly the same behavior in the spectral reflectance, or in the spectral setup. So you will have a decline in the first 3 bands, then an uprising in the reflectance here in the 4th bands, and then a decline again up to the 7th band. If you would like to show some differences, then just go to the water area and once again select the water, and what you will see now is that you will have another reflectance. So just see those pixels. As you can see here, this was our forest area and this is the water, so you don't have the uprising here in the 4th band. And you can also edit this using the chart legend. Just make the first 6 profiles, I think, where the forest area, apply that, and there we go. Then the 7th is once again forest area, and you can also mark that down here. So just type in forest, and apply that. And once again, you can also concentrate on the other graphs, use color blue, maybe apply that, and so you have a really good feeling of what are objects that are in the manner of their spectral information near to each other. Let us go to another area. So this is very urbanized area in the western part of Berlin, and just use a spectral profile tool on this object. Yeah, I'm not really sure what it is, but I think it's some kind the trading center. And as you can see, you have a different spectral behavior of this pixel. So you have a decline up to the 2nd band, then an uprising here in the 3rd, a major decline in the 4th band, and once again the uprising. And as you can see, the I don't know, the form or maybe the signatures really similar to each other. You have some major differences in their magnitude, but the form is the same.